Today we're working on how to write equations of parallel and perpendicular lines. So before we work on some of these problems, there's a couple things you have to remember. So number one, you have to remember what we talked about the other day, and that is, what do you know about parallel lines and what do you know about perpendicular lines? Well, the basic is parallel lines are lines that never intersect no matter how far you extend them. And then perpendicular lines are the lines in your graph that cross at 90-degree angles, okay? Now, the thing you have to remember for these notes, however, is what do you know about their slopes? So if you need to look up in your notes, parallel lines have the same slope. And the reason for that is because the steepness of the line has to be the same in order for them to never intersect each other. Perpendicular lines have what are called negative reciprocal slopes. So negative reciprocal slopes. And so what that means, the negative part means that they have different signs. And then the reciprocal part means that the fraction is flipped. So I'll just put fraction is flipped from each other. And so that's one thing that you will have to know to be able to do these problems today. All right. The other thing that you will have to know is the different forms of a linear equation. So we're dealing with lines, and so you're going to need to know these different forms because the problem may ask you to put the equation in a certain form. Okay, so point slope form, you're going to have a point and a slope to be able to put it in this form, but it's going to be y minus that y1 value equals your slope, and then it's times x minus your x1 value. Okay. Slope-intercept form, if you have to put it in that form, it's going to be in the y equals mx plus b form. So your y is by itself, and then the x part is in the front on the other side of the equation. And then standard form is ax plus by equals c. And so remember, the a, b, and c are going to be numbers, and they're going to be integers. And then remember, the a has to be positive. Okay, so from here we can start doing these problems. So we're going to just work through a couple examples so you can see how these problems are to be done. All right, so number one, it says the line, you're going to write the equation of the line using the given information. It says the line is parallel to this line right here. So notice this is not the equation of the line. It's saying that the line that you're writing the equation for is parallel to this line. And then it says that the line that you're writing the equation for passes through that point. Okay? Well, if you remember when we were writing equations of lines, you had to have two pieces of information. If you were able to have the slope and you had a point that it goes through, you could very easily find the rest of your information. Or if they gave you like the slope and the y-intercept, it was pretty easy. You could just plug it in. But notice they're not giving you the information here. So what you're going to do is you're going to have to find it. So they actually are kind of secretly telling you the slope. If you look, it says that they're telling you this line is parallel to this one. So parallel lines have the same slope. So if it's parallel to this one, all you have to do is find the slope of this line, and you'll know what the slope is of the line that you're writing the equation for. So what is the slope of this one? Well, if you look, this equation is in slope-intercept form, and so the slope will be in front of your x. So if I look right there is my slope of that equation, and if it's parallel to that, then the slope of the line that I'm writing the equation for would be the exact same number. So then the slope would be 1/2. Okay, so that's my slope of my line. And then notice it gives you another piece of information. It's telling you that it passes through that point. So that's really all you need to be able to write the equation. And since they're giving me a point that it goes through and the slope, it's going to be easiest to use point slope form. Okay, now we did talk about if you liked the slope intercept form better, you can use the slope intercept form to find the y-intercept and then plug that in. But if the problem asked you to put it in point slope form, you would have to use point slope form. Okay, so let's go ahead and use point slope form to write our equation of the line. All right, so point slope form, remember you copy this down, but you're going to leave a blank for where you're going to plug in. So we're going to leave a blank for the y1, the m, and then the x1. Okay, so it's going to be y minus a blank equals a blank, x minus a blank, okay? And then you plug in. So remember, your y value goes with your y. So this is my x, that's my y. So my 8 will go here. The slope goes here. So my -1/2 will go there. And then the x value goes with the x. So my -6 would go here. All right? So from here, if they asked you to put it in point slope form, you would just have to, like if you had something like this, like minus a negative, you would simplify that part, but then you would already have your answer. So notice minus a negative will become a positive. So if I have to put this in point slope form, it would be y minus 8 equals, and then you bring the -1/2 times x, and then that'd be plus 6. So you would be done at this point if they just asked you for point slope form. Well, what if they asked you to put it in these other forms? Well, to put it in slope intercept form, you have to get the y by itself. So I would have to simplify a little bit. So I'd have to distribute my -1/2. So I'm going to bring my y minus 8 down. So if I distribute my -1/2, it would be -1/2 times x, which is -1/2 x. And then -1/2 times 6, that would be -3. And then from there, I've got to get the y by itself, so I'd have to add 8 to both sides. And so these will go away. And then y equals my -1/2 x would come down, and then -3 plus 8 would be +5. And notice, y is by itself, I've got the x part up front, so that's your slope-intercept form. So if they asked you to put it in slope-intercept form, this would be your answer. My goodness, my lead is breaking like crazy today. So equals -1/2 x plus 5. So there's a slope-intercept form. Then if they asked you to put it in standard form, remember, standard form, you've got to get your x's and your y's on one side, and then you've got to get your constants on the other. And then if you have a fraction for the a, you're going to try to get that to where it's not a fraction and you want it to be positive. So let's start by getting our x's and y's to the other side. So I'd have to get this -1/2 x to the other side. So to do that, I'd have to add 1/2 x. So I'll add 1/2 x to both sides. And notice these aren't like terms. And so you would just write it out. So since my x has to be first, it'd be 1/2 x, and then my y would go behind it. So 1/2 x plus y. And then these will cancel. And then that 5 will be left on the other side. All right. So everything's positive, but notice you have a fraction in front of the x, and you want these to be integers as much as you possibly can. So to get rid of that, all you have to do is multiply by what's called the reciprocal of this. Or, like, since you're dividing 1/2 times something is the same thing as dividing by 2, you can take your whole equation and multiply it by 2, and that'll get the 2 off the bottom. So notice, if you take 2 times the 1/2, that's 1. So you're left with just a 1x plus, but then you have to distribute it to the entire equation. So it'd be 2 times the y, which would be 2y, and then 2 times the 5 over here would be 10. So that would be your standard form. Okay, so we've got you covered on every possible form. And now they won't ask you to write it in every form, but this is just kind of how you would do that. All right, so let's do one more where we're going to do that, and then we'll talk about specific types of problems. All right, so number 2, it says the line is perpendicular to this line and then passes through that point. So again, you want to find what the slope's going to be, and then they tell you that it passes through that point, so you can use that point for the rest of it. So again, they're giving you the slope here like they did in the other one, but it's kind of a secret way that they're giving it to you. So if you look, they say that this line that you're writing the equation for is perpendicular to that line. So again, go back up here. You know that perpendicular lines have what are called negative reciprocal slopes. So that means they're going to have different signs and the fraction's going to be flipped. So if it's perpendicular to this one, well, that one's in slope-intercept form. And notice your slope for this one would be -4. So then for the line that you're writing the equation of, it's perpendicular to it. So that means you have to take this one, change the sign, and then flip it. So if I do that, this -4 is understood to be over a 1. So if I change the sign, it's going to be a positive number. And then if I flip it, it would be 1/4. So that's the slope of the line that we're writing the equation for. And then we know that this line goes through that point. So there's my point. And then I'm going to plug it in my point slope form because I have a point and I have the slope. And so it's easiest to do that. So I'm going to copy that point slope form down and I'm going to leave blanks. So it'd be y minus blank equals blank, x minus blank. And then I'm going to plug in. My y value goes with my y. So my 10 goes here. My slope goes here. So it'd be 1/4. And then my x value goes with my x. So my x would be 0. Right, and then I simplify. So if I had to write the point slope form, then you would be done. And now, again, if you wanted to simplify this, you can. But for point slope form, you could technically leave it like that too. So I'm just going to copy that over here for point slope form. So that would be one way you could write it. Or if you took x minus 0, it'd just be x. So you could have 1/4 x on this side. Okay, but that's point slope form. To put it in slope intercept form, like we talked about up here, you've got to get the y by itself. So I've got to do a little simplifying. Okay, so I'm going to bring down my y minus 10. Typically, I would distribute my 1/4, but notice x minus 0 is just x. So on this side, you just end up with 1/4 x. Okay, so from there, to get the y by itself, all I have to do is add 10. So I'd add 10 to both sides. So -10 plus 10 is 0. And so on this side, I'd end up with just y. And then on this side, the 1/4 x, I'm going to put in front, and then that plus 10 goes behind. So that would be my slope-intercept form. So it would be y equals 1/4 x plus 10. All right? And then to put it in standard form, you remember, always want the number that's in front of x to be positive. If you look, it's already positive. So you do not want to subtract it over and make it negative. So what you're going to have to actually do is you're going to want to move the y over here, but then you'll have to move that 10 over to the other side. Okay, so you could do this at the same time. You'd have to subtract 10 to both sides. I'll put a little wall here. But then you'd also have to get this y to the other side, so you would want to move the y. Now, if that bothers you, you could do one at a time, but some of you I know like to multitask, so if you want to multitask, that's what you have to do, all right? So then the y minus y will go away. This 10 minus 10 will go away, and then you essentially write what's left. So on this side, you had to subtract 10, so you've got -10 on this side. And then 1/4 x minus y won't simplify, so I'm just going to write it out. Let me erase that. So it'd be 1/4 x, and then you have the minus y. And now notice, typically that number's on the other side, so I'm going to move that -10 to the other side. And then you, again, do not want a fraction definitely in front of your x. So just like what I did in the other problem, when I multiplied by 2 so I could get rid of my fraction. Well, what would you have to multiply this by? You'd have to multiply it by 4. So I'm going to multiply my entire equation by 4. So 4 times the 1/4 will be 1. So you're just left with x there. 4 times the negative y would be negative 4y. And then on the other side, 4 times negative 10 would be negative 40. So there is my standard form. Okay, so now we're going to just deal with special types of problems that you could see, and so we won't be doing as many forms since we've kind of already practiced that. So the next types of problems, you're going to notice the equation's a little different. So like in number 3, you have to write the equation of a line that's perpendicular to this line and passes through that point. This is one of those special lines that we talked about the other day. It's a constant line. And so if they give you one of these problems and they're giving you a constant line, it actually is easiest to graph it to find your answer. So we're going to start by actually graphing this line, and then the equation that we're writing has to be perpendicular. That line has to be perpendicular to the line that we're going to graph. But then it has to pass through that point. So we're gonna talk about it. So you'll grab a piece of graph paper. You're gonna start by graphing the line that they're giving you. So x equals 5. Remember, you go to your x-axis. So this would be your x-axis. That would be your y-axis. And you go to that number. So 1, 2, 3, 4, 5. And then remember, x equals 5. We'll hit the x-axis at that point and nowhere else. So it has to be a vertical line. So you're gonna draw your line, and then you're going to kind of read through this problem and just make sure that everything kind of matches with that problem. So it says the line that you're writing the equation for is perpendicular to this line. So we're writing, remember, perpendicular means it crosses at a 90-degree angle. So we're writing the equation of a line that is perpendicular to that line, okay? But it has to pass through this point. So you're going to graph that point, so -3, -1, and we're going to think, okay? We have to have a line that passes through that point, but it has to cross at a 90-degree angle with that line. Well, you can visually kind of see it. Perpendicular means that it has to cross the 90-degree angle, and if it has to go through that point, well, that would be this line right there. So you've got the line, now you just have to tell the equation of it. So it's horizontal, and so remember, horizontal lines are y equal a number of lines because it's crossing the y-axis at a point, and then you just have to tell where it crosses the y-axis. So this line crosses the y-axis at -1. So there is your answer, because that line is perpendicular to that and passes through that point. So your answer would be y equals -1. So if they give you a problem like that, you just graph it to find your answer. All right? So the next one, it says we have to write the equation of a line that's parallel to this line. Notice that's a constant equation, and passes through this point. So if it's a constant one, go to your graph. So I'm going to flip this over, and we're going to graph. So the first thing you do, you graph that line. Y equals a -2. If it's y equals, you go to the y-axis and put a dot. So y equals -2 would be right here, and then it's going to cross the y-axis there and nowhere else on the y-axis. So these are your horizontal lines. So this is the graph of that line. But remember, this is not the line we're looking for. This is just kind of to help you see what's going on. So the line that we're dealing with is actually parallel to this line, okay? So remember, parallel is going to be to where it doesn't intersect, all right? So we're writing the equation of a line that's parallel to this line, and it passes through the point 5, -12. So we're going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's that point. So graph the point goes through. And then you're going to think, how can I draw a line that goes through that point but is parallel to that line? Well, parallel means it doesn't touch, so it'd have to, or it doesn't intersect, so it'd have to look like this. And then all you have to do is write the equation of that line. So this is a horizontal line, so remember that will be a y equals line, and then you just tell where it crosses the y-axis. So this one would cross at negative 12. So this, the equation of that line would be y equals negative 12. Okay, so that's the main part of today. The next two examples are examples where they give you equations and you have to do a little work first. So we're going to do those and then we'll be done. All right, so number 5 says you're writing a line that's perpendicular to this one that goes through that point. And you only have to put it in slope-intercept form for this one. All right, so if I do this, perpendicular means that it's going to have a negative reciprocal slope. If you look at this though, this is not in slope-intercept form to begin with. So what I have to actually do to begin with is put this in slope-intercept form so I know my slope. Okay, so that means I have to get my y by itself. To do that, I got to start by getting my x to the other side. So I'm going to subtract my 9x. So that'll go away. Then I have 3y equals, I'm going to pull that negative 9x to the front. And then I have to divide by 3. And when you divide by 3, what you're doing is dividing everything by 3. So those will go away. On this side, I have to divide the negative 9 by 3. So I get negative 3x. And then 12 divided by 3 would be 4. Okay, so now we can look at this and do the problem. So we're writing the equation of a line that's perpendicular to this line. So the slope of this one, the number in front of x, is negative 3. And so we have to do a little work to figure out what the slope is of the line that we're writing the equation for. So remember, it's perpendicular to this. So you have to take this, flip it, and change the sign. So this is like a 3 over 1 right here. So if I flip it, it'd be 1 over 3, and it was negative, so then I made it positive. So this would be the new slope that we're dealing with. And then it goes through this point, negative 1, 1. Okay? Oh. Then we can plug it in. And so if you wanted to use slope-intercept form to go straight and write it in that form to begin with, you can. But since we've been using point-slope form, I'm going to show you how you could start in point-slope form. So if you do that, write down your point-slope form and leave blanks like we've been doing. Then you plug in your y value. So your y goes with your y. Your slope goes here. And then your x value, which is negative 1, goes with your x. And then to put it in slope-intercept form, you're going to solve for y. So I got to distribute my 1/3 first. That'll be plus a positive. So my y minus 1 comes down. Distribute my 1/3. I'd have 1/3 x plus 1/3. And then from there, you're going to add your 1 to both sides. So when I add my 1 to both sides, let me just write it over here. It'd be y equals 1/3 x, and then it'd be 1/3 plus 1, so you would get 4/3, and then that's your slope-intercept form because the y is by itself. Okay, so then the last one, it says you're writing the equation of a line that's parallel to this line and then goes through that point. Well, notice I can't tell the slope yet because my y is not by itself. It's not in slope-intercept form. So to get my y by itself, well, the opposite of multiplying by negative 2 is to divide. So I'm going to divide all this by negative 2. And then those will go away. And I have y equals divided into each one. So 4 divided by negative 2 is negative 2. And then that'd be negative 2x. And then negative 5 over negative 2 would be a positive, and we're just going to leave it as a fraction. Positive 5 over 2. So we're writing the equation of a line that's parallel to this line. So find the slope, and then think about parallel means that they have the same slope. So my slope for the new line would be the same as that one, negative 2. And then this line has to go through 8, 10. So same thing as before. You put it in your point slope form. So it'd be y minus something equals something, x minus something. All right, y value goes here. Y goes with the y, slope goes there, and then your x goes with your x value. Okay, so this one we have to put in standard form. So that means you've got to get your x's on one side or your x's and y's on one side and your constants on the other. Okay, so got to simplify a little bit. So I got to distribute my -2. So -2 times x is -2x. And then -2 times -8 would be a +16. And then from there, I've got to add my 10 on both sides. And so when I do that, I got y equals -2x plus 26. All right, so we can't stop until it's in standard form. Well, standard form, you just have to get your x's and y's on the same side, and then make sure that your a, the number in front of x, is not negative, and they can't be fractions. All right, so if I move this x over here, notice it'll make it a +2x. So I'm going to add my 2x to both sides. Let's see if I can squeeze it in here. So add 2x. So when I do that, I'd have 2x plus y on this side. Those go away, and then it equals 26. So that is my standard form, because everything is an integer, and then my a is a positive number. So there you go.